Hello everybody and welcome to our live stream, Stop Sleeping on the Elimination Method. Really quickly, just want to confirm, can everybody see and hear me okay? If so, go ahead and say something in the chat. Looks like we have a bit of a lag here, about like a minute, maybe a little bit less, so that's not too bad. Okay, looks like we're good. Perfect. Let's get just a couple more yeses in, or nos. If you can't hear me, I don't know how you could respond, but that works perfectly. Okay, awesome. It seems like everybody can see and hear me okay. Thank you so much to everybody who introduced themselves in the chat. Glad to have you all here. Seems like we're, all in a variety of different places. So for me, it's pretty early. For a lot of you guys, looks like it's relatively late. So thank you, at whatever time you're here. If you're here in the morning, thanks for waking up. If you're here in the afternoon, thanks for taking your lunch break. If you're here, in the evening or even at night, thank you so much for, again, dedicating your time to being here. We're going to try to make it worth it to you guys. Like I mentioned in the chat, this session is going to run probably around an hour. Probably the actual content portion of it is going to run like 45 minutes to an hour. And then we're going to take some Q&As at the very end. So that is what to expect. If you need to leave early, totally understand. This is going to be posted on the GMAT Club channel. So you can, again, watch after the fact. If you want to also, review a little bit later, this will be there. Perfect. So we're going to go ahead and launch in. Kind of before we start, let me just quickly introduce myself. My name is Erica John. I am a GMAT instructor as well as a GMAT content writer. That means that I have in my day written quite a few GMAT questions, explanations, lessons, all that good stuff, which means that I've spent a lot of time with these problems. I've also worked in a variety of other standardized tests, including the GRE, the SAT, the ACT. So this has been kind of my life full-time for a while. So I'm really excited to be sharing some of my insights with you guys today, and hopefully helping you guys to attack some GMAT quant a little bit harder and a little bit more effectively. So today in our live stream, we're going to be talking about the elimination method and why you should stop sleeping on it, why you should be using it more frequently, specifically when substitution fails, but even when it doesn't. All right, perfect. So a quick kind of outline of what we're going to be doing today. First, we're going to start with what the elimination method is. Maybe some of you guys need a little bit of a review on that. Then we're going to talk about when the elimination method is helpful but not necessary, right? Then we're going to talk about when the elimination method is necessary. It is the only algebraic way to solve. And then we're going to talk about when the elimination method isn't actually used for elimination. Kind of weird. It's in the name. Seems like that should be the purpose. Not necessarily. So, what the elimination method is. So, to start, this is not process of elimination. So if you're here expecting this to be a lesson on process of elimination, that's not what this is. It's a really great topic. It's something that you guys definitely want to utilize, etc. But that's not what we're going to be doing today. We are going to be solving directly for the answer. Got a question, is this going to be quant-centric? Yes. Yes, it is. Because the elimination method is something that we use exclusively in quant. So process of elimination we see in both sections. We see that in quant, we see that in verbal, but the elimination method is specifically an algebraic tool. So again, if you were here for process of elimination, we are not talking about that today. I still recommend that you hang out because this is a really great topic, but that's not what this is. So what is the elimination method? So the elimination method is a method for combining systems, so systems of equations, systems of inequalities, basically where we have two pieces with some sort of equals or less than or greater than or whatever sign in it. We have two of those and we want to bring them together. And we do that by adding or subtracting. Typically, the purpose of that being to eliminate a variable. Now we're going to talk a little bit more about how to do that in just a second, but to kind of justify why we're doing this live stream, why this is valuable to you guys. In my experience, there are two things that are true of the elimination method, which is that it's kind of under-taught in high school algebra. And that's true from my own experience because, going into this field, I did not remember the elimination method whatsoever. Now, maybe I was just sleeping in class in high school, but I've heard kind of the same experience from a lot of my students, which is that the elimination method is something either they don't remember really at all, or it's something that was kind of touched on in high school, but it's something that didn't sink in, that wasn't really explained as being particularly important, so it didn't, it didn't stick. It's not something that they are ready to use on the GMAT. So as a result, it's kind of underutilized by GMAT test takers. Now, in a couple of cases, that'll be okay, right? It'll just make you a little slower, but in other cases, it is absolutely necessary to be able to use the elimination method on these algebraic questions. So this is actually a really critical part of your algebra toolkit. So today we're going to talk through when it's helpful but not strictly necessary, so it's going to save you time and make your math easier. We're going to talk through when it is necessary, when you absolutely do need to use the elimination method, and then again, when it's used for some interesting stuff. So starting with when it's helpful but not necessary. And this is the context that most people know the elimination method from. So most people know the elimination method as an alternative to substitution when you have a system of equations, right? So you've got one equation, usually with like an x and a y, or an m and an n. Then you've got another equation, which has those same variables typically. Now, what we want to do with those two equations, typically if we have two variables and two equations we can solve, three variables, three equations we can solve. Not always true, but that's kind of the general rule, true most of the time. So what we want to do when we have these systems typically is isolate for a variable, and then isolate for another variable and another, depending on how many we have, and then use the variable we find to solve for the other one, right? So the goal is to get each variable kind of on its own. Now, what most people use to do this, what most people really remember from high school, because that's where algebra is taught, it's not really something that we see in college, what most people really remember is substitution. Right, so substitution is where we have two equations, where we take one of those equations and solve it for a single variable, and then plug that into the equation. Let me know in the chat if you remember that, right? Or if you've used that recently. If you've been studying for the GMAT, that's probably something that you've seen a lot, right? And probably use like almost daily, right? So most people know it as an alternative to substitution. Now, when we have a system of equations, substitution always works, right? It's functional. So we don't technically need the elimination method. And that's something that I know stuck with me, right, from high school. So I liked the substitution method. I used it all the time. Plugging in the answers is another option that we can use. We're going to be mostly focusing on algebraic solutions today. We will kind of talk about how like picking numbers and plugging in answers can be valuable, but that's, again, not really the focus here. Substitution is typically going to work when we have systems of equations, right? So a lot of people think we don't need the elimination method because substitution pretty much always works. So they just totally forget about it and don't use it. However, even in systems of equations, when the elimination method is not necessary, the elimination method is actually often more efficient and more effective for our work. So we want to make sure that we have the elimination method as an option to use instead of substitution when isolating a variable either takes more time, right? It's slower, it's less efficient. We don't have a ton of time on this test, so we want to save it where we can get it. Or it creates difficult calculations. So let's actually take a look at two examples here. So in these examples, we want to solve for x and y. Now, this first example, if we take a look at this, this would actually be really quite simple to do via substitution, right? Maybe isolate this x by adding y to both sides, and then plugging in 1 plus y in for x in the first equation, solving for y, and then plugging back in for x. That totally works. But it's actually significantly faster to use elimination. So again, elimination is where we either add or subtract these equations from each other, typically with the goal of eliminating a variable. So let's try that really quickly. So if we take these two equations, we can notice here, okay, I've got two positive x's, I've got a positive y and a negative y. If I add this entire second equation to the first equation, I'm going to go kind of straight down the line since fortunately everything's lined up. I've lined up my x's, lined up my y's, lined up my values. So adding these two x's together, I get 2x. Okay, positive y plus negative y, I get nothing, right? They cancel each other out. So now my y is gone. It's been eliminated, right? Elimination method, that's where the name comes from. All right, and then we add 7 plus 1, we get 8. Divide both sides by 2, x is equal to 4. All right, that was 2 steps, right? That was not very hard. Whereas if we were doing substitution, we'd be doing minimum 3, maybe 4, right? So again, not that much faster, but a little bit faster. And the other thing that's valuable about this is that when we're doing substitution, when we're doing extra steps, we're opening ourselves up to the possibility of making more mistakes. The more work that we have to do, the more calculation we have to do, the more likely it is that we're going to make a tiny error, right? Lose a negative, or, you know, add something wrong, or drop a coefficient, something like that, right? So this limits our steps, gets us through it faster, and prevents us from making mistakes. Well, it doesn't prevent us from making mistakes, but it lowers our risk of making mistakes. Now, another option here. Let's say we wanted to solve for y. Now, what we could do is we could just plug x equals 4 into one of these equations. Bing, bang, boom. Done. Solve for y, right? If we plug into the first one, x equals 4, subtract 4 from both sides, y equals 3, right? Very easy. But if we were solving directly for y, didn't need to solve for x, what we could do instead, setting up these same equations, is subtract the second equation. Now, we're going to have to be really careful to make sure that this negative applies to each term. This is maybe a little bit error prone, so what you might want to do is distribute the negative. That can help. When we are subtracting, all we're really doing is multiplying by a -1 and then adding. So it's basically the same operation. So x minus x cancels. Y minus -y, that's the same thing as y plus y. We get 2y. All right, and then 7 minus 1, we get 6, y equals 3. Again, a 2-step process, relatively fast. So for this option, substitution would totally work. It just might be a little tiny bit slower. So isolating for a variable takes a little bit more time here. Now here, this guy. Looking at this one, what do you think? What would be easier, substitution or elimination? Let me know what you think in the chat while we kind of get rolling with this one. What do you think would be easier, substitution or elimination? And why? While we do that, I'm going to start kind of lining this one up. Yeah, elimination for sure. I did see one person say substitution. I would not substitute this one, and there's a reason for that. So I have just kind of rearranged this one to line up the terms, which is something that we're going to be dealing with later. But the reason for that is if I take a look at this first equation, there is no way to simplify that, right? All of those coefficients are the size that they have to be, right? We've got 4x, we've got 5y, we've got plus 11. And then down here we've got -2, -13, plus 21. Again, we can't simplify this, right? There is no simplifying it. So if we were going to substitute, we would have to deal with these coefficients. So probably the easiest one to isolate for would be this x down here. But if we did, right, we would, yeah, these figures are quite bogus, right? So if we did isolate for x, we would end up with fractions. We would end up with 13 over 2 and -21 over 2. Then we'd have to plug that in. Now, fortunately, we're multiplying by a 4, right, which is going to simplify that out, but we're still dealing with fractions, which are not our friend, right? They're better than decimals, they're better than, you know, percents or ratios, but if we can avoid them, we should, because they are yeah, difficult. I like what Naman's saying there, don't like 21 or 13. A lot of folks are, recommending that we multiply by 2. So that's a really great idea. So our first step is just to kind of get it in the form that this one was already in, right, where all the terms are lined up. So went ahead and moved everything over. So that should be, all right. So being very careful here, might want to do this in multiple steps so you don't make any mistakes. I did it in one because we have limited space on the whiteboard. So since we have negative 2x, we're going to add that over to this side to get positive 2x. Okay, we have positive 13y over here. We're going to subtract it to the other side to get negative 13y. And then we have our positive 21 already over here. Perfect, so that is rearranged, good to go, right? But nothing's going to eliminate, right? So if we go, thank you to those who said positive 2x there, yeah, be really careful. I highly recommend you do this in multiple steps or else you're likely to make a little mistake if you're not paying attention. So if we are paying attention to 5y and negative 13y, right? To get that to have the same coefficient so that it would eliminate, we would have to do something to this equation and this equation, right? Not fun, don't want to do it. And if this is review for you, awesome, perfect. We're going to be getting into some more complicated applications in just a couple of minutes. So to make it so that this will eliminate, what's going to be easier is to eliminate this x, right? Because 2x goes into 4x. We can simply multiply by 2. So if we take this whole thing and multiply it by 2, we're going to get 4x. We're going to get minus 26y plus 42. All right, perfect. Nope, not plus 42, plus 32. Keep me honest here in the chat. All right, so plus 32. Okay, so then, okay, now we're going, these two line up. I've got a positive 4x, so I'm going to go ahead and subtract. Now, another move that I could do here, I could have multiplied by negative 2 and then added. Again, just the same thing. Subtracting is the same thing as multiplying by negative 1 and then adding. So I'm going to subtract this whole thing. All right, 4x minus 4x, that cancels. Okay, I've got 5y minus negative 26y. Okay, perfect. So when I have 5y minus negative 26y, that's going to go to, that's going to end up becoming 31y. Correct? We good here? Yeah, so then 5y plus 26y is going to go to 31y. Then we're going to have 11 plus 32, which again, no, that should not be 32. I don't know what I'm doing here. Sorry, plus 42. Holy moly. We're going to add those together and we are going to get 53. And then we're going to solve accordingly. So making sure that all lines up, multiplied by 2, blah, 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 and then we're going to solve accordingly, and that's going to equal 0. So that is going to be how we isolate for one of our variables. Perfect, yeah, thank you for those of you who said 42. I appreciate it. So again, we want to be really, really cautious as we go through. One really useful move is to take little loopies. Bring your 2 like that. So we go, okay, that's 4x, that's negative 26x, that goes there, and that becomes 42. And then we go accordingly. So then we subtract, again, good move to go negatives. And I'm making all the mistakes here that are really, really common. So if you are making these mistakes, hey, learn from me, right? What we should do is be really careful, even when we're working on the whiteboard. So we want to make sure that each of these applies. If you really struggle with this, a good move is to multiply by that negative 2 and then add to be really quite sure. So thank you to those of you who are keeping me honest. We have 11 minus 42, which should lead us to negative 31, which now that makes a lot more sense. A really good move here is if you see that your numbers don't make a lot of sense, right? You're going, this does not, add up correctly. This is not going to give me a pretty number. Maybe just review your math to see if everything went okay. So here I got a little lazy, multiplied in my coefficients without, doing the loopies. I subtracted without doing the loopies. That's going to get us in trouble. You are a little bit late, but that's okay. This is going to be recorded. You missed me making a bunch of calculation mistakes. So if you want to see that, you can learn from my mistakes here. So now we have 31y minus 31. We can isolate for y. 31y is equal to 31. Divide by 31. Now y equals 1. At this point, we can plug in 1 for y and then solve accordingly for 4x. So maybe using this first equation, 4x is equal to 5 times 1 plus 11. So that's going to be 4x equals 16, or x equals 4. So provided you don't make calculation errors here, this method is significantly faster, right? No worries about being late. Totally cool. You'll be able to watch the rest later. So this method is significantly faster than substitution, right? If we were to substitute, we would be dealing with complicated fractions. We're even more likely to make any sort of calculation errors. So this is a really great place to utilize the elimination method. It is here about 3 steps to solve for the y, and then to solve for the x, just a couple more. So 2 or 3 more. So with substitution, this would be significantly more complicated, so elimination is our guy. Now, this is kind of the most basic application of this, so let's do a really quick problem where, again, substitution would work, it would be fine, but it would just maybe take 1 or 2 extra steps. So I'm going to give you guys 2 minutes to solve this one. This is a word problem, so make sure that you are building out your equations carefully, and then we will be back together to go over what the answer for this one is. 2 minutes. Yeah, stepping in quickly to kind of reiterate what GMAT Club said. We don't have a poll to submit. We're going to keep this kind of low tech. Go ahead and submit your answer in the chat when you've got it. And yeah, this should be lift. Thanks to the person who shouted that out in the chat. Let's take about 30 more seconds, and then we'll be back together. All right, coming back together, most folks got this one right. I am seeing kind of a trap answer here, so we can talk about that really quickly. So going ahead and translating this. So the first sentence, in a weightlifting competition, the sum of Draymond's 2 lifts was 750 pounds. To make sure that my variables are logical, I'm gonna label them F and S for first and second. So I'm going to go ahead and go, okay, F plus S equals 750. Okay, moving on to the second sentence. If twice the weight of his first lift, so 2 times F, was or equals 300 pounds more than, so that's 300 plus, the weight of his second lift. Perfect. Okay, that's my second equation. We want to find the weight in pounds of his first lift. So we are looking to isolate for F. So whether we use substitution or elimination, we want to ideally get F by itself. Now, if we were going to be doing substitution, we could isolate for s here and then plug 750 minus f into this equation. It's the exact same math that we're going to do here, it's just a little bit slower. Now, if we wanted to do the elimination way, what we can do is we can first just move our s over to the other side. So we're going to subtract s from both sides. So we have 2f minus s equals 300. Now, because we have a positive s and a minus s, if we add these two equations together, the s cancels, we get 3f is equal to, all right, 1,500. Simply divide by 3, and we get f is equal to 350, confirming that that's what I'm solving for. Yes, it is. My answer is D. So this is just a couple of steps. Again, substitution works. It's just a little bit slower. Yeah, someone here is recognizing that I have, I do appear elsewhere on YouTube. Yes, I do. So if you answered E here, this is the value for the second lift. So if you did get E, make sure that you are defining your variables carefully and that you are checking your answer at the very end. So here we go. Elimination, useful, but not 100% strictly necessary. Let's talk about when it is necessary. So if you guys were here for the Inequalities live stream a couple of weeks back, then you guys will have seen that the elimination method is one of our key tools when doing inequalities, specifically systems of inequalities. Now, with systems of inequalities, substitution does not work, right? The idea behind substitution is that we isolate for one variable, so say x equals 2y plus 10. Now, because x equals 2y plus 10, we can take 2y plus 10 and plug it in for x. It is the same thing. Now, when we have a system of inequalities, there is no way to find an equivalent for one of our variables. We can say, okay, x is greater than 5, but then I can't plug 5 in because x is greater than 5. It's not 5. Even with greater than or equal to 5, x being 5 is only one option. There are tons of other options. Right now we can try plugging in numbers, but that's not particularly algebraic. That's not particularly efficient. So what we can do instead is the elimination method, which is really the only way of algebraically solving systems of inequalities for a single variable. So we need to follow certain rules when we do this. So rule number 1, the signs must face the same way. So if you have a greater than, you have to have a greater than. If you have a less than, you have to have a less than. Greater than or equal to, greater than or equal to, you get it. And then secondly, you have to add. And this is kind of building on that principle that we've been talking about, which is that addition and subtraction are basically the same thing. But subtraction is where we multiply by 1 and then we add. But multiplying by negative 1. When we multiply by negative 1 on an inequality, it flips the sign, right? So then our signs don't face the same way, and then we get into trouble, right? So make sure your signs are facing the same way. If you need to flip them, maybe multiply by a negative, right? And then once your signs are facing the same way, add them. So what this technically means is that if you subtract two inequalities where the signs are opposite, that's the same thing as adding where the signs are the same. If you want to remember that, absolutely feel free. But it's maybe just a little more complicated, or maybe just a little simpler to flip the sign first and then add. So alternative, subtract opposite signs. All right, perfect. Moving along to a couple of examples, which I'm going to try very hard not to make any calculation errors on. But if I do, again, keep me honest in the chat. Don't know why the whiteboard makes things weird. So we're going to go ahead and go for it. So first step, probably want to simplify this down a little bit. And we want to determine the value of x as specifically as possible. So that means our y, we want it to go away. Now, yeah, inequalities, they're rough, but elimination method makes them easier. So, looking at this one, some folks are going to immediately launch into multiplying by 3 on the top. But there's actually a much easier method. Hopefully you guys might see down here, 12, negative 3, and 9. All of those are divisible by 3. So actually, I can simplify this bottom equation, make these numbers easier for myself. So that's what I'm going to do. I'm going to go ahead and divide this whole thing by 3. I'm going to get 4 minus y is greater than 3. Okay, now we notice, okay, signs are facing the same way. Got a positive y and a negative y. If I add these together, I am going to be able to get rid of my y. Now I might want to reduce or to kind of simplify this even further by maybe combining like terms, etc. I'm not going to right now just because I don't want to, but that is a good move. So adding these together, adding the whole thing, 12 plus 4 is 16. Positive y plus negative y is nothing. 4 plus 3 is going to be 7 minus x. Okay, perfect. Now I could add my x to this side and subtract my 16 to the other side. That is a move. What I can also do is I can subtract 7 from both sides. So I have 9 is greater than negative x. And then to flip that sign and get rid of that negative, I'm going to multiply by a negative 1 on both sides. So I get negative 9, flip the sign, is less than x. And I can check really quickly with my loopies. Okay, negative 9, sign flips, positive x. Cool. So did our due diligence with the loopies here, and we got this as simple as it'll go. We know that x is greater than negative 9, but that's all we know. All right, perfect. Moving right along to example number 2. Now this might look a little weird. This looks like it's one inequality. It's all in one row. How can we rewrite this to make our lives easier? In the chat, when you think you know how to rewrite this guy. I'm gonna give you guys 10, 20 seconds to make this so we can do elimination. Now a lot of folks will try to, add x to both sides. That's okay, so that works. That's one move. We can add x to both sides, and then we can, simplify from there. That's one move. But again, thinking about elimination. Divide by 2. I probably wouldn't do that there because I'm then going to get some fractions. But what I could do is I could make 2 equations split in the middle. Nice job, Rashab and Barath. So, and Alina, nice job. So what I'm going to do is I'm going to make this 2 different equations. And then I've got y is less than 2x minus 1, and then I'm going to kind of solve accordingly. So to get everything kind of moved around, looks like my signs are facing the correct direction at the moment, right? So those are both less than signs, but I want to get everything on the same side. So I want to line up my numbers, my values, I want to line up my x's, I want to line up my y's. So I'm basically going to swap this whole thing, right? So I'm going to subtract y to this side, going to subtract x to this side, and then I'm going to add 1 to this side. Perfect. So making sure that that aligns. All right, subtracted the y, subtracted the 2x, added the 1. Perfect. And again, if I wasn't on a whiteboard, I would probably do this in more steps. Alina says, can we flip the sign of one of the 2 equations and eliminate a variable? Yeah, so at this point we can eliminate a variable. So if we go ahead and go here, if we look at that, we've got a y and a negative y. The signs are aligned. So when I go ahead and add this together, got 15, negative x minus 2x is negative 3x, less than 0. Okay, now we're going to isolate for the negative 3x. So we've got negative 3x is less than is less than negative 15. Caught it. Again, if you're making these kinds of mistakes, writing out minus 15 on both sides is helpful. All right, there's an x in there. Divide both sides by negative 3. Remembering when we divide by a negative 3, we have to flip the sign in addition to changing this to positive. So we've got x is greater than 5. And we're done. So this is another method here. This is a presentation you will see on occasion. This is a really great way to simplify this using the elimination method. So elimination method is basically the only real algebraic way to solve these systems of inequalities. Perfect. Cool. All right, seeing that kind of repeated in the chat, that works. Yeah, what we could also do is here ignore that y and then simplify for x. Just using 14 minus x is less than 2x minus 1. That also totally should work. So Moving right along to another example of this one. So let's take a look at this first part together. So this is a data sufficiency question, right? When you see greater than 0, what does that make you think? Greater than 0. That should make you start thinking about a very specific type of number property. Yeah, it means positive. Nice job, Alina. Yeah, and everybody's coming in with that one. So this basically we can rewrite is xy positive? Okay, so notice how they're asking for something a little bit strange. They're asking for xy, they're not asking for x, they're not asking for y. So I don't really care what x is, I don't really care what y is. I care if xy is positive. Yes, and yeah, guys, you are totally nailing it. That means that they have the same sign. Do x and y have same sign? So either both positive or both negative. If they are both positive, sufficient. If they're both negative, sufficient. If one is positive, one is negative, I mean still sufficient, because we can answer the answer is no. But if we can go either way, they might be both the same or they might be different, then that's insufficient and we are not going to pick that answer. So I'm gonna have you guys try this on your own. There should be a couple of answer choices we can eliminate right away. When you think you've got the answer, go ahead and throw it in the chat. Let's take 2 minutes on this one. All right, still getting some answer choices in there. Let's go ahead and take a look at this together. So actually right off the bat, hopefully, even just by plugging in numbers, we can tell that statement 1 alone is not going to be sufficient, right? If x minus y is greater than -5, we could rearrange this. Basically, all that's saying is that x and y have a difference between them of -5, right? So there's 5 between them. So they could both be positive, they could be negative, one could be positive, one could be negative, not sufficient. So A is out and D is out. Looking at statement 2 alone, same deal, right? That means that x and 2y are 7 apart. So again, We don't know. They could both be negative, could both be positive, or one could be negative, one could be positive. So B is out. So at this point, we're between C and E. And at this point, we have a 50% chance of getting it right. The most common answers here were C and E, which is good. If you did not get that, hopefully plugging in numbers would help you there, or maybe rearranging a little bit. Maybe playing devil's advocate. So taking a look at these together. So at this point, I want to start combining these equations to see if I can learn something about X, learn something about Y. Now, I'm seeing that folks were able to find stuff out about Y for sure, right? So that one's kind of the easier one to figure out. So we definitely want to flip this sign. So we're going to take this and we're going to multiply it by -1. So we're going to get -X plus 2y is greater than 7, right? Whole thing multiplied by -1. Loopies, just to check. Cool. All right, so we have -x plus 2y greater than 7. Okay, now we can add these together. So ignoring this one. So we've got x plus -x, those cancel. We've got -y plus 2y, that's going to leave us with y greater than, that just drops through, -5 plus 7, that's going to be 2. So y is greater than 2, which means y is positive. That is for sure. Awesome. Oh, but we don't know anything about x, so not sufficient, right? Well, can we find something out about x? Let's see if we can take these two equations and do anything to them. So what could we do to this top equation and this bottom equation so that we can instead eliminate for y and get x? Any ideas? Any ideas in the chat? But what we can do to get it so that we can eliminate y instead of x. Because right now we can't. We have -y and positive 2y, right? That's not great. Yeah, Shrey, nice job. If we multiplied this first equation by 2. So if we multiply this first equation by 2, yeah, you guys are getting it now. And again, loopies, to be careful. Looks a little messy on the board, but on your paper, I swear it helps. I would not multiply, we could multiply -2 if we were using the original equation, but I'm just going to use this one down here, so I only have to multiply just 2. All right, so multiplying by 2, I'm going to get 2x minus 2y is greater than -10. Cool. That makes sense. All right, and then I'm going to bring this equation over. I've got -x plus 2y is greater than 7. Okay, perfect. I'm going to add these together. So 2x plus a -x, we're going to get x. Nice. All right, -2y plus 2y, I'm going to get nothing. And then -10 plus 7, I'm going to get -3. Now at this point, a lot of folks go, cool, I solved for y, I solved for x. Great, I know x, y, I'm done. But we want to pay slightly closer attention here, right? We want to go, okay, if x is greater than -3, that means it could be positive, but it could also be like -2. It could even be 0, right? That would also mess things up. So x can be positive, negative, or 0. If it is positive, the answer will be yes. If it is negative or 0, the answer will be no. So here, the answer is actually E. Right, so x would have to be positive if we wanted xy to be positive, but that's the question we're asking. We don't know if xy is positive, right? That's what we want to know, and we don't know, right? X can be positive, negative, or 0 given this statement. So is this true? Don't know. Right? So be careful here. Remember what's your question and what are your statements. Perfect. All right, answer here is E. I'm going to give you guys a weird one, and I'm just going to kind of throw you into the fire with this one. First off, I want to just kind of say one of these statements is easier than the other. Start with the easier statement. It's going to help you rule out quite a few answer choices. Then move on to the harder ones. See what you can do there. Let's take 2 minutes and then we'll meet back up. This is slightly different. Notice, we're not solving for x, we're not solving for y, we're not solving for r, not solving for s, not even solving for x minus y or r minus s. We're seeing is x minus y greater than r minus s. That's a weird thing. Give that a shot. All right, I'm gonna go ahead and pop back in because you guys are doing a really solid job with this one. So let's go ahead and take a look. So one of these statements should look much easier than the other, right? Which statement looks easier to you guys? The 1 or 2? I'm just gonna hang out for like 10 more seconds. Yeah, the second statement, right? We should be able to look at the second statement and go, okay, if I plug in those numbers, I'm gonna get an answer, right? I don't know if that answer is yes or no. I don't care because I'm going to get one of those answers for sure. So I know that statement 2 is definitely sufficient on its own, which means A is out, C is out, E is out. It's either B or D. So we're down to a 50% chance of getting this one right. This is definitely sufficient on its own. Really good move with data sufficiency is start with the easier statement. It's going to make life easier. So okay, we know that statement 2 is sufficient. Let's look at statement 1 on its own really quickly. So we're ignoring statement 2, just pretending that doesn't exist. Now we've got x is greater than r. Okay, so that's got 2 of the letters. And we've got y is less than x. So that's again 2 of the letters. Now we might be thinking, okay, how in the world am I going to eliminate? These 2 equations share nothing in common. And this is where we're getting into kind of weird territory. Because like I mentioned earlier, the elimination method can be used even when we're not eliminating. So let's try to combine these, right? We see that we have one equation with all 4 of these variables. It'd be really neat if we could get these 2 equations into one. We could also potentially work with the question stem. It might be a little bit easier to work with the answer choices here. But that's a really good move. Often manipulating the question stem is a good move as well. So taking a look at this, if we have x is greater than r and y is less than s, okay, I want my signs to align, so I'm going to multiply the second one by -1. Doing my loopies, boop, boop. So I'm going to get -y is greater than -s. All right, I'm going to rewrite this guy up here so it's a little bit more visible. So that was x is greater than r. Okay, getting rid of this guy in the middle. Adding these together, because again, remember, our rules still apply. We still need to add. Signs need to face the same way. Adding them together, we get, okay, x minus y, so nothing eliminates. That's okay. Is greater than r minus s. Would you look at that? We got exactly what the question asked for. So this is sufficient. So the answer here would be D, which most of you got. So this leads us into kind of our final point here, which is that the elimination method gets really interesting, gets really useful Oh, sorry, really quickly confirming. Oh, sorry, I read the question. No, actually the question asks for x minus y and r minus s. Yeah, so you might have read that one wrong, Aditya, but yeah, it does say x minus y is greater than r minus s. X minus y greater than r minus s. Perfect, so we solved exactly for what we were looking for. So, moving in, elimination method gets really particularly interesting when we use it to combine systems of equations or inequalities and not eliminate any variables. That is allowed, right? So we're using the elimination method for something other than elimination. So we can use the elimination method, saying that you manipulate the question. Aditya, yeah, that's also another option, totally cool. Yeah, that works as well. We can use the elimination method to combine systems of inequations whether or not any variables are eliminated, right? So we can add, we can subtract, totally cool, totally valid. Now the same goes for systems of inequalities, but again we have to follow the rules. So we have to add, that is for sure, and we need to make sure that the signs face the same way. Or if we're getting fancy, we can subtract if the signs are opposite. Again, totally fine. Now, how to know that we want to do this, right? Because most of the time we do want to eliminate a variable. But here, we can tell that we don't necessarily want to do this if the question asks for something weird or specific, right? So in this question, we asked for something very strange, right? We wanted to know if x minus y was greater than r minus s. So that means we don't care about x, we don't care about y, don't care about r, don't care about s. We care if x minus y is greater than r minus s. So if the question asks for something weird and specific, we often want to build that weird and specific thing. And the elimination method is a really great way to build weird and specific things. Let's go ahead and take a look at an example here. I'm going to let you guys try this one on your own. So this is a system of equations, right? So addition and subtraction are both valid here. Bharath, I might be able to do that at the very end, but we're going to go ahead and move on to this problem right now. So I'm going to give you guys about 2 minutes. Go ahead and solve. Be careful. Careful here. So notice that they are solving for something very strange. They're solving for 6xy. Not solving for x, not solving for y. Solving for 6xy. Give it a shot. All right, stepping in, yeah, we are seeing the right answer pretty commonly, and we are seeing the most common trap answer pretty commonly. So let's take a look really quickly. So we see, okay, we've got systems of equations. We're trying to solve for 6xy. Now, if we're thinking common algebraic equations, we know that with a quadratic, we get xy in the middle term, right? So we're going, okay, there's no middle term here, but I can make a middle term with this, which is a perfect square. Now, we remember if we have a perfect square, we have a plus b squared. That's going to equal a squared plus 2ab plus b squared. Or we can just FOIL. So being really careful and applying that here. All right, a squared is going to be 4x squared. Okay, the b squared is going to be 9y squared. Now ab would be 6xy. So 2ab is going to be 12xy. Be really careful here. All right, perfect. That's going to equal 150. Okay, I see 12xy. That's very close to 6xy, so I'm going to try to get that by itself. Okay, then, again, we could plug in 100 for 4x squared plus 9y squared, or we can just go, okay, 4x squared plus 9y squared is equal to 100, and then subtract the whole thing. So subtracting, we get 12xy is equal to 50. Divide both sides by 2. 6xy is equal to 25. Answer is C. So if you fell for D, be careful. Remember your common algebraic equations. Careful with the middle term. Let's try another one. This relies on a lot of the same principles. It's a little bit harder. So again, we're looking for something weird. We're looking for AB. Not looking for A, not looking for B. Looking for AB in terms of x and y. So see what you can do with these two equations to manipulate them, and then maybe bring them together. Let's take 2 minutes on this one. Answer in the chat when you think you've got it. All right, seems like folks are getting the right answer. I did see a solution in the chat using substitution for this one. You can absolutely do that. However, elimination is going to go a little bit faster here, especially if we recognize AB as, again, that middle term, right? And recognizing A plus B and A minus B as pieces of perfect squares. So if we're going, okay, wait, let me build out my perfect squares and see if I can isolate for that middle term, that AB term. So then we can go, okay, from the first equation, squaring both sides, A plus B squared is equal to x squared. Okay, that's going to simplify to A squared plus 2AB plus B squared equals x squared. Cool, I'm going to get rid of that. Then my second term, A minus B squared equals y squared. All right, expanding this, we're going to get A squared minus 2AB plus B squared equals y squared. All right, getting rid of that. Now we should notice, if we subtract this second equation, right, these have a lot of terms in common. This A squared term and this B squared term is going to drop right out. So dropping that out, so A squared minus A squared, nothing. 2AB minus negative 2AB is the same as plus 2AB. We get 4AB. The B squareds drop out, and then we get that equals x squared minus y squared. Okay, really close. Divide both sides by 4. We get the answer choice C. Now again, can you do this via substitution? Yes, you can. Could you do this via picking numbers? Yes, you can, right? So is the elimination method, again, fully necessary here? No, but it is a really efficient way to get through this problem. And in a lot of cases, substitution really isn't going to do us much good. It's going to lead us down some pretty bad paths. So make sure that you are utilizing the elimination method for systems of equations where you're solving for weird things. All right, one final example. In a word problem, specifically a work rate problem, which is something that a lot of folks struggle with. So, quick review on work rate before we jump into this together. Thing you gotta know. You gotta know that work is equal to rate times time. Therefore, we've got rate is equal to work over time. You need to know that. You also need to know that rates are additive, right? So if we have the rate of A plus the rate of B, we are going to get the rate of A plus B. So the rate when they work together. Similarly, if we have 2 of A working and 2 of B working, we can add their individual rates together, multiplied by 2, to get the rate of 2A and 2B. So 2 times the rate of A working alone plus 2 times the rate of B working alone gives us the rate of 2 A's and 2 B's working together. So make sure that you know this. Let's go ahead and really quickly translate the first sentence of this equation together. So together, 15 type A machines and 15 type B machines can complete a certain job in 4 hours. What do you guys think? So really quickly, what is the rate if they complete one job in 4 hours? So what is the rate of all of those machines together if they complete one job in 4 hours? In the chat. Not looking for the answer yet. Just the first sentence. Yeah, it's going to be 1 over 4. So their rate combined is 1 over 4. Okay, using this principle up here, how can we express this in terms of just type A's rate and type B's rate? In the chat. So how could we finish out this equation using RA and RB? We've got 15 of A and 7 of B. Together, they make 1/4. Yeah, perfect. I would not do time here, right? This is rate specifically. Rates are additive here. So be careful with that, Barath. So we want to do 15 of rate A plus 7 of rate B is going to give us 1/4 as the total rate, or 0.25. Nice job, Janedo. Okay, perfect. Go ahead and on your own, translate the next sentence as well as the question. Now notice again, the question is asking something weird. It's asking how many hours, so we're going to time, not rate, would it take one type A machine, one type B machine, and one type C machine working together? So again, we don't care about the rate of A, don't care about the rate of B, don't care about the rate of C, care about one of each together to complete one job. Go ahead and answer in the chat when you think you've got it. Take about 2 minutes. All right, some folks are getting this one, some folks are maybe feeling a little bit confused, so let's go ahead and go through this together. So, if we go ahead and take a look at the second sentence, okay, together 8 type B machines and 15 type C machines can complete the same job in 11 hours. I'm actually going to write this a little bit smaller just so that we can utilize our space. So from our first sentence, we said, okay, 15 of rate A plus 7 of rate B equals 1 over 4. All right, for our second equations, we've got, I'm actually going to spread this out just a little further for reasons that will be revealed shortly. All right, for the second equation, we got 8 type B machines, so 8 of rate B, and 15 type C machines, 15 rate of C, can complete the same job in 11 hours, so that's 1 over 11. Now we know that we want to solve for rate of A, rate of B, and rate of C together, right? Now we have 2 equations with 3 variables, right? So it's probably, we're feeling a little bit like, ooh, maybe I can't do that, right? I can't solve for each individually, but we don't have to, because again, we're not solving for each one individually, we're solving for one of each together. So what we might notice here, oh, that's funny, that both of those are 15. And when I take 7 plus 8, wow, that also gives me 15. So maybe I want to do some elimination here, right? But not actually eliminating, just combining these equations. Now when I bring these together, I'm going to get, and I'm running out of room here, so I'm going to go ahead and do this at the top. 15 of rate A plus 15 of rate B plus 15 of rate C is equal to, all right, going to get a common denominator here of 44. So multiplying this guy by 11 over 11, multiplying this guy by 4 over 4, we're going to get 11 over 44 and 4 over 44. Okay, adding those together. Perfect, I'm going to get 15 over 44. Wow, this is convenient. And then I can divide both sides by 15. So I'm going to get RA plus RB plus RC equals 1 over 44. So the rate for all 3 of them together is 1 job per 44 hours. Therefore, it takes 44 hours to complete 1 job. Answer is C. Now, a couple of folks expressed these rates as 1 over A, where A is the time for one machine A to complete a job, or 1 over B, where B is the amount of time it takes one machine B to complete a job. That's also totally cool. It is the same thing because, again, it's just a rate, but that rate is expressed as work over time. So if you did that, totally cool. You don't have to, but you can. So this is another application of the elimination method. So here we really do need to eliminate to be able to solve for what specifically they're asking for. We can waste a lot of time doing substitution to try to solve for each rate A, rate B, and rate C, but that's going to get us in trouble. So, quick summary on this one. The elimination method can be a helpful alternative to substitution for solving systems of equations. It's really useful when it is faster than eliminating for a variable. It is also really useful when solving for a single variable, isolating for that variable creates nasty math like fractions. It's often less error prone. However, be careful because it is still error prone. You can still make mistakes even if you literally teach this for a living and are a 99th percentile scorer. So be careful. Try to limit the calculations you're doing, but be careful with them. Similarly, it can also be a necessary step for solving systems of inequalities. So isolating for variables in systems of inequalities, we can use the elimination method because the substitution method does not work. And then finally, it is a useful tool for creating new equations and new inequalities from systems, whether or not variables are actually eliminated. So we can use the elimination method without eliminating anything. So this is particularly useful when you're solving for something weird, something strange. So when you see that the question is asking for something weird, see if you can do this. So the elimination method should be a well-used part of your algebra toolkit. Make sure that you are using it, that you are bringing it to the table because it is your friend. All right, we're going to go ahead and take some Q&As really quickly. If you have questions either about Veritas Prep or about the questions that we talked about here today, I'm going to hang around for about 5 to 10 more minutes before I jet. Thank you so much for being here today. If you are leaving, thank you for participating. Thanks for keeping me honest. And if you have questions, again, throw those in the chat. So I'm seeing Aditya says, can you subtract two inequalities? You can only subtract two inequalities if the signs are opposite. So I actually had a question from Bharath earlier to see if we could do that on this excuse me, this example. So we could do this if we had x is greater than r and y is less than s. So either we want to add two inequalities where the signs are the same or subtract two inequalities where the signs are different. So here, if the signs are different and we want to get fancy, what we can basically do is subtract this bottom equation. But when we're subtracting, all we're doing is we're multiplying by -1, which flips the sign on the bottom, and then adding, right? So if we were to do this, we would get x minus y is greater than r minus s, which again is exactly what we are solving for. So yes, you can technically do this. You will have the sign of the thing you are not subtracting. However, if you do this, be extremely, extremely careful because it is error prone. It's a little bit more safe to just multiply by that -1 and then add. This is basically combining two things. Perfect. All right, let's see, going back to our summary page. All right, let's see what else. Any webinars on absolute values or inequalities? There is actually a GMAT Club webinar on inequalities that was like a couple of weeks ago. Feel free to check that out on the GMAT Club channel. It deals with some of the stuff that we talked about today, so the elimination method for systems, but it also goes into more depth on inequalities. So if you struggle there, that's a really good one. Again, it's on the channel. Yeah, Kanha says we can't solve individually here. I'm guessing you're talking about this problem. Yeah, so this is one where solving individually via substitution is not really going to work for us. So this is one where the elimination method is definitely our guy. All right, let's see. Recommend something about decoding the question stem for probability questions and DS questions. Okay, so I appreciate your question. Not really the topic of the webinar, which is why we weren't talking about it before. Decoding the question stem for probability and DS, my big recommendation is slow down. If it is a long question stem, particularly if it's a word problem, a lot of people try to read the whole thing and then they read it like 5 times and they don't get anything out of it. Don't do that. Try to take it up until a piece of punctuation or like a connector word, like say a fanboys. So for and, nor, but, or, yet, so. Stop there. Process what you have so far and then move on to the next piece. Process each piece at a time, then put it together. Probability in particular is one where that kind of chunking method is particularly valuable. You're probably not going to solve for the whole thing at once, so take it one step at a time. When is the next session from Veritas? Great question. I don't know for sure. I think we've got one coming up in a couple of weeks. If you keep an eye on the GMAT Club channel, they will update you on that. So it might be me, it might be another instructor. Keep an eye on the page and you'll find out. Strategy on solving problems in less time. So that's such a broad question. Couple of recommendations is make sure that your toolkit is in great shape. So elimination method is critical. So that's just your kind of foundation. Then make sure that you're really fluent with that toolkit so that you can bust it out at any time. More than that, it's recognizing when to use different tools in your toolkit, right? So one thing here, when we notice that the question's asking for a weird thing, trying to use maybe the elimination method to solve for that weird thing. Now, other things about solving questions in less time, take more time with the question stem. That is particularly important. And then try to save time on calculations, doing less, maybe by using the elimination method. Oh, great question. There is an absolute value session coming up very soon. Great. Check out the notifications. Thank you, GMAT Club. There is an event calendar that is now linked in the chat if you want to take a look at what is coming up. All right, perfect. I'm actually going to go ahead and step up to the computer so I can look at previous messages in case I missed anything. So I will be right back. All right, I think I got pretty much everything in the chat. Thanks so much for being here again. If you have more questions, again, please do throw those in the chat. I'm going to go ahead and step off camera, but I am going to be in the chat for another like 4 minutes or so, so until 10:20 a.m. Pacific. Thanks again for being here. Really appreciate you guys. And again, this will be posted live on the channel later, so if you do want to review anything that we went over, feel free. Yeah, thanks for being here. If you have any questions, again, feel free to throw those in the chat or in the comments, and I'll try to respond to those personally later. Thanks. See you guys later.